Howdy and welcome back. We've made it to data representation in the computer. The first kind of primitive type that we're going to explore the representation for is going to be integral numbers. Before we get into that, let's just talk about data representation in the computer from a broader perspective. Recall that most modern computers deal with memory as chunks of bits of sizes that are powers of 2. A byte of memory, so a byte, you've probably heard this terminology, is going to usually be defined as 8 bits, so a sequence of 8 binary digits, so ones and zeros together. That will be called a byte of memory. Data is going to be represented by a fixed number of bytes with the amount of bytes dependent on the kind of data or underlying data structure. For instance, an int, I believe that's going to be 4 bytes on my machine. A double precision floating point value is going to be 8 bytes. So 8, how many binary digits is 8 bytes? Well, each byte is composed of 8 bits, so we're going to come out with 64 bits contributing to that. We're not going to consider like these larger kind of conglomerates or sequences of bytes. Instead, we're going to try to keep things simple to keep our perspective focused. So we're going to talk about integral numbers, and as I introduce it, we're going to use a half byte just to keep the discussion simple. So again, we only have a limited number of bytes to represent data on the computer, with the amount dependent on the kind of data. For the purposes of our discussion on integral numbers, let's say that we only have a half byte or 4 bits to represent the integral numbers. This will have implications and kind of the range of values that we can store. So the positional number system makes it easy to represent positive numbers using straight binary encoding. For instance, we could go ahead and use all 4 bits to go ahead and represent or encode the decimal value of 11. This is great for positive numbers, but the question becomes, how can we represent negative numbers alongside positive numbers? We're going to consider 2 different ways. One way we'll see is going to be a little problematic. The next way is going to be how we can effectively use 4 bits to satisfactorily represent both positive and negative numbers in a way that makes sense when it comes to basic arithmetic. So let's go ahead and move into, first, we'll talk about sign magnitude notation, and then we'll talk about 2's complement. So with that, I'll see you in the next video.